Good morning students. Today we will continue with our same chapter, that is calorimetry, and today we are going to continue with the topic of calorimeter. Now first of all I just want to give a quick revision of this term, that is calorimetry. What is calorimetry? It is the measurement of heat when we are placing two objects together. One is hot and another one is cold. So definitely there is exchange of heat. That means from a hot body the heat goes to the cold one. What happens then? Then the hot body loses the heat and the cold body gains the heat. This measurement of heat, that is known as calorimetry. So to measure this heat we need a apparatus that is known as calorimeter. Now what is calorimeter? Calorimeter is a cylindrical vessel which is made up of copper that is used to measure the amount of heat gained by a body when it is mixed with another body. Whatever bodies we have, suppose we have cold water in it and we are going to add a piece of ice in it, so definitely the temperature of the water, that is going to change. Initially maybe the temperature is at 20 degrees and when you are going to add the ice, the temperature of the water definitely going to change. It reduces to 15, it reduces to 10, or maybe it reduces to 5 degrees. That study we can do with the help of this calorimeter. So again I am just repeating it. Calorimeter, it is a cylindrical vessel which is made up of copper. It is used to measure the amount of heat gained by a body when mixed with another body. Whatever body we can have. Instead of adding ice, we can have a hot piece of iron. We can add hot piece of iron in water. We can add hot piece of copper in any other liquid, in any other substance. Definitely the temperature of both the substances is going to change, because definitely the heat is going to transfer from hot body to cold body when both the bodies comes in contact with each other. So that changes what is the total measurement, how much heat is gone from hot to cold, how much cold body is going to gain, how much hot body is going to lose. All that we are going to read out with the help of the calorimeter. Now we have to study about all the parts of which this calorimeter is made up of, and why are we using those parts over there, that we need to study. Okay, so first of all, as I told you, calorimeter is a cylindrical vessel which is made up of copper. So this inner reddish lining, that shows you copper over here. Okay, so this is made up of copper. This is copper vessel. Now the question is, why copper is used over here? Copper is used, first thing, because copper is a good conductor. And as I told you in my previous video, copper is a good conductor, and all the good conductors, they absorb very less amount of heat and quickly raise its temperature. So as it is a good temperature, so whatever content is added over here, okay, into the substance, whatever is the initial substance, whatever we are adding over here, so this copper is going to absorb very less amount of heat and quickly acquires the temperature of the contents present in it. Okay, so there is no loss of heat, very less amount of heat it is going to absorb from the content. और ये जो thermometer है that we are using here to measure the change in temperature, so that is able to measure that change in temperature, and as very less amount of heat is taken by copper from the content, so there is hardly any change in the calculations, hardly any effect on the calculations. The second is the copper has low specific heat capacity, because just now I told you all the conductors, they absorb very less amount of heat to raise its temperature. That means its specific heat capacity is less. What it means, why its specific heat capacity less, help us to use this copper in calorimeter. The reason being is heat taken by calorimeter is less from the contents, and it is easily able to acquire the temperature of the content without taking much heat from the contents. जितनी हीट कंटेंट्स की थी, अगर उनको 50 पर होना चाहिए था, they will be at 50 only. Hardly any change will be hardly any change in the temperature, and this copper itself is going to attain the same temperature which the contents has. Because of these two qualities, it is a good conductor and its specific heat capacity is very low. Okay, next thing, this copper, this is fitted in a wooden jacket. This is wooden jacket, and the lid which we are using over here, that is also made up of wood. This is the lid, and this outer covering, That is this outer covering, this is your wooden jacket. Why we are using wood here? To provide a better insulation. If there is a better insulation, there is less exchange of energy from the outer surroundings. Means the temperature which is present in the outer surroundings, that is not going to affect the contents present inside the calorimeter. So to provide a better insulation, we are using wooden lid and we are using wooden jacket. So we have discussed about thermometer used to measure the temperature, copper vessel, good conductor and has low specific heat capacity, and able to acquire its temperature of its content very easily. Then wooden jacket and wooden lid, it is used for better insulation. Now coming on to this filling. Inside this wooden jacket and in between this copper vessel, we have filled wool. Why wool? Because wool is a poor conductor. And when we are using poor conductors anywhere, they avoid heat loss because of conduction. They are not going to conduct heat from here to here or from here to here. So to provide or to avoid heat loss by conduction, we are using poor conductors, and the best poor conductor which we can use over here, that is wool. Okay, the next thing is this complete calorimeter is painted, is polished from inner as well as from outer side, and the reason to polish this calorimeter is it is used to avoid loss of heat by radiation. No heat loss will be there due to radiation, and to avoid that we are using a polished surface. We are polishing it from the outer as well as from the inner side. So hence in total what can we say? Calorimeter is a device. It is able to maintain the temperature of the contents in itself only. It is not going to exchange the temperature from the outer surroundings. It is designed in such a way. So this is all about calorimeter. Again, I am just quickly recapitulating. It is made up of wooden lid, wooden jacket for a proper insulation, copper vessel because copper vessel is a good conductor and has low specific heat capacity, hence able to acquire the temperature of its contents very easily without absorbing much heat from the contents. Okay. Then wool is a poor conductor, hence avoid the heat loss due to conduction. It is polished because then we can reduce the heat loss due to radiation. So overall this complete setup is known as calorimeter. Now we have to study about principle of calorimetry too. Or we can say this principle of calorimeter is also known as methods of mixture. Means when we are adding more than one thing, and then what will be the change in their temperature, what will be the final temperature of the mixture, how temperature will be increased or decreased, or you can say how heat can be gained or lost by the object, that we are going to calculate with the help of this. For this we need to take care, or we can say this principle of calorimetry or methods of mixture, that is based on the law of conservation of energy. For that we need to assume that energy can neither be created nor be destroyed. Means energy is conserved. When energy is conserved, whatever amount of energy is gained by one body, that is similar to the amount of energy lost by another body. That will remain same, and this is same procedure we are going to use over here, that is law of conservation of energy. For that we are going to assume that two bodies are present. Suppose one is A, another one is B. This is body A and this is body B. The mass of body is M1, the mass of body B is M2. The specific heat capacity of body A is C1. The specific heat capacity of body B is C2. The temperature of body A is T1 and the temperature of body B is T2. And we are assuming that the A body is at higher temperature. That means we are saying that T1 is greater than T2. That means this body is acting as hot body and this body B, that is acting as cold body. Now what will happen when we will place these two bodies in contact with each other? Then in that situation, this hot body, the heat will transfer from hot body to cold body when these two are placed in contact with each other. And there is a loss of heat energy from body A. Loss of heat energy. And definitely this body B, as it is a cold body, it is going to gain the heat from A. So there is gain of heat energy. There is gain of heat energy. Okay. But till what time this keep on going? Till both the bodies or till this complete setup attains a thermal equilibrium. I hope everybody is aware about thermal equilibrium. It is the state when both the bodies which are placed in contact to each other when they were at different temperature and comes to the same temperature after exchanging the heat from each other. That state when both the bodies they attain the same temperature and there is no flow of heat from one body to another body, that is known as thermal equilibrium. Suppose this body is at 50 degrees Celsius, this is at 30 degrees Celsius. When we will place these two bodies, 50 वाले से heat जाएगा 30 वाले में, but till what time? Till both the bodies will attain the temperature of 40 degrees Celsius. At 40 degrees Celsius, both of they have same amount of heat, we assume it. Okay, if both of they have same temperature, that means there is no hot body, no cold body, means there is no flow of heat, and this situation is known as thermal equilibrium. So for this also, when we are talking about this A is hot body, there is loss of heat and this is gaining the heat energy. But according to law of conservation of energy, we are assuming that there is no loss of energy. When we are saying it, there is no loss of energy. So what can we say? The loss of heat energy by who is losing? By hot body is equal to gain of heat energy, and who is gaining it? This cold body by cold body. These two are equal to each other, because we are saying that according to law of conservation of energy there is no loss of energy. When there is no loss of energy, so whatever is lost, that is gained by another substance, then only we can say this is followed. And this loss of heat energy by hot body is equal to gain of heat energy by cold body. This is known as principle of calorimetry. This is known as principle of calorimetry, or we can say this is known as principle of methods of mixture. ये दोनों ही नाम से आता है. And sometimes this can also be asked कि it is based on which law of energy. So this is based on law of conservation of energy. So this is the you can say representation of this formula, or you can say representation of this law. The loss of heat energy is equal to gain in heat energy, because we are assuming there is no loss of total energy. Fine. Now we'll start with the mathematical expression of this. How to express it in mathematical form. For this, whatever we have assumed earlier, we are using that only. We assume that mass is m1 for body A, specific heat capacity is C1, and the temperature is T1 initially. And for body B, mass is m2, specific heat capacity is T2, and temperature is T2. Okay, so, and we also assume that T1 is greater than T2, that means this is hot body and this is cold body. Okay, now as we are aware that specific heat capacity, when we are writing, how we are writing heat required in that situation, we have done one formula and we are aware heat required is given by, that is given by mc delta T. Okay, this is heat required. That means there is loss of heat energy and there is gain in heat energy. Means either the heat is given or either heat is taken. So one is giving the heat, another one is taking the heat. So both the ways we are going to equate it. How are we going to equate it? So let us find out heat energy lost by body A first. So how can we find out heat energy lost by body A? Because this body A is losing the heat energy lost by body A, that will be given by Q is equal to, that is mass of body A is m1, specific heat capacity is C1, and delta T. This delta T is change in temperature. Now for this, when we are talking about both the bodies are in contact with each other or both the bodies are mixed with each other, a final temperature will be attained. जैसे हमने इस केस में किया था, यहाँ 50 था, यहाँ 30 था, finally कितने पर आ गया था? 40. So I am saying let final temperature be T for this. Let final temperature for this situation be T. That means this hot body is losing the heat and the temperature of the body falls. It comes from T1 to T. Okay, initially it is high and now it is coming to T. So that means this is the bigger value and this is the smaller one. So this is change in temperature. This change in temperature will be given by higher value, say compare T1 minus T. So it can be represented this way. So this delta T we can put this way. So this is M1 C1 T1 minus T. This is first equation. Okay. Now at the same time, whatever energy is lost by body A, that same energy is gained by body B. So that you can write here, heat energy gained by body B. How can you write it? That is given by M1. No, this is body B. Don't write M1 here. This is M2. You are talking about this. This is M2. Specific heat capacity is C2 and T2. Now here is rise in temperature because this is gaining the energy. So here is rise in temperature. And in the previous one, what happened? There was fall in temperature because this is losing the heat. So when the temperature is increased, that means this value is less and the final temperature is T. This value is more. And always when we are subtracting zyada mein se kam wala. So this value is more. That means delta T will be written as T minus T2 because temperature T is more. It is gaining the temperature. Ye zyada hai aur ye kam hai. So T minus T2 will be given as delta T. You can substitute this value over here. That becomes M2 C2. This is T minus T2. That will be your equation. Okay. Now what we are supposed to do according to principle of calorimetry? What we know? We know that heat gained by body A is equal to heat lost by body B according to principle of calorimetry. So write it here according to methods of mixture or principle of calorimetry, heat gained by body heat gain, or I will write loss here, heat lost by body A is equal to heat gain by body B. Just put the values from these two equations. This is M1 C1 T1 minus T. This will be M2 C2 T minus T2. This will be the mathematical expression to express principle of calorimetry. When two bodies of different masses, different specific heat capacity and different temperature are mixed together or bring in contact with each other, how can we write mathematically the principle of calorimetry or methods of mixture? We can use this equation where M1 is the mass of the body which lost the heat, C1 is the specific heat capacity of the body which loses the heat, and this is the fall in temperature because heat is lost. Okay, M2 is the mass of the object which gains the heat, C2 is the specific heat capacity of the object which gains the heat, and T minus T2 is the rise in temperature, this because this body is gaining the heat. So this is the mathematical expression for principle of calorimetry. And beta, please remember आपको ये आना ही चाहिए, otherwise you cannot do the numericals of this chapter, of this part. Even you cannot find out this T1 minus T. These two things are also to be learnt very carefully. Why I subtracted T1 minus T and why I have written T minus T2. हमेशा बड़े में से छोटा वैल्यू घटेगा, ये याद रखना चाहिए आपको, ठीक है. And the same principle you are going to apply over here. Here when we are talking about lost by body, heat is lost, that means temperature is reduced. ये final था आपका temperature mixture के बाद वाला, ये initial temperature था तो heat loss हुआ है तो मतलब temperature कम है, बड़ा value ये है, छोटा value ये है. When we are talking about heat gain, तो आपका जो final temperature आया ये बढ़कर आया है, ये पहले छोटा था तो बड़े में से छोटा minus होगा. When you will do these two things carefully, if you are able to do it, then you can solve your numerical properly. Fine. So do one thing. Revise this expression, read out the content from your book and try to complete the question answers of your book exercises barring the applications only. I hope you are able to do it.